Okay, namaste everyone. Okay, we are again present here and going to discuss in the same topic, unit force, verification of gravitational force with mass and the distance. So here in the A, we'll discuss when the mass of the body is doubled, keeping the distance between two bodies constant. Okay, in the previous class we have started and we know that this is the two object, or you can say the two masses. Let us consider this is the body A, this is the body B. They both have the masses m1 and m2, and the distance between them two from the center is D, and gravitational force between them is F1. Now, we have studied gravitational force between them is given by, suppose this is the F1, then gravitational force between them is given by F1 is equal to gm1 into m2 by d square. Suppose this is the equation 1. Now, according to the condition, here is the when the mass of the body is doubled, means mass of you can say the mass of a body is doubled. Now this is the body A. Let us this double the mass. So when the mass of the body is doubled, means one body. Here is the situation. There is the two body. We have to double the only one mass of the body. Suppose this mass A body is double. So we can say m1 is equals to 2m1. m1 is equals to 2m1. Now again from the gravitational force between them. Now same condition F2. Suppose this is the F2. Here in the first cases there was the F1 and we got the equation 1. And now again in the when the masses is changed. Now F2 become G instead of the M1. You have written here, we have written here 2M1. So G 2M1 into M2 by D square. Now F2 is equals to 2gm1 into m2 by d square. This is the equation 2. Now from this equation 1 and equation 2, let us divide the equation. This is the 2 by equation 1. Then numerator, reversing this, numerator and denominator, we get f2 by f1 is equals to 2gm1 into m2 by d square, and reversing this d square by gm1 into m2. Now gm1 into m2, gm1 into m2, both is cancelled. D square, both is cancelled. We get f2 is equal to f1, and multiplying this f2 is equal to f1. Hence, here is the 2f1. So, hence gravitational force between them is doubled when the mass of the body is doubled, keeping the distance between them is constant. Okay, second, when the mass of both bodies is doubled, just we have a study, mass of one body is doubled. Now here the mass of both bodies is doubled, keeping the distance between the body constant. So we have studied, let us consider body A and B have masses m1 and m2. The distance between them from the center is D, and gravitational force between them is F1. So F1 is equals to G m1 into m2 by d square. Now when the mass of both bodies is doubled, keeping the distance between them constant, then m1 is equals to 2m1, m2 is equals to 2m2. Now from the figure, this m1 become 2m1, m2 become 2m2. Now gravitational force between them is given by F2 is equals to G2m1. Instead of the m1, we have written 2m1, and instead of the m2, we have written 2m2. So F2 is equals to 4gm1 into m2 by d square. This is the equation 2. Now from the equation 1 and equation 2, we get here F2 by F1 is equals to, this is the 4gm1 into m2, 4gm1 into m2 by d square, and reversing it d square by gm1 into m2. Now here d square cancelled. For that gm1 into m2, gm1 into m2 both also cancelled, and we get F2 is equals to 4F1. Hence, gravitational force between them is increased by 4 times. This increased by the 4 times when the mass of the both bodies is doubled, keeping the distance between them constant. Case C, when the distance between both is halved, keeping the mass constant. Here the distance is halved, but the mass is constant. Now, by this figure, according to Newton's law of gravitation, F1 is equal to gm1 into m2 by d square. This is the equation 1. Now, according to the case, when the distance between them is halved, mass is constant, but distance between them is halved, then d is equals to 1 by 2d, or you can write d by 2. So from this figure, this is the mass is same, but distance is here. This distance becomes the half, that is the 1 by 2d. So gravitational force between them is given by F2 is equals to gm1 into m2 by, instead of the d square, you can write 1 by 2 d whole square. Now F2 is equals to gm1 into m2 by, this d become d square, and 2 into 2 4, so d square by 4. Now this 4 goes up, so that's why F2 is equals to 4 gm1 into m2 by d square. This become equation 2. From equation 1 and 2 we get F2 by F1 is equals to, instead of F2 equation, you can write here 4 gm1 into m2 by d square, and F1 multiplying this d square become up, d square, you can write d square by gm1 into m2. Now d square and d square cancelled, gm1 into m2, gm1 into m2 both cancelled, and F2 become, by multiplying this, 4F1. Hence, gravitational force between them is increased by 4 times. This gravitational force is increased by 4 times when the distance between them is halved, keeping the mass constant. Case D, when the distance between them is increased by 2 times, keeping the mass constant. Now here, this d distance increased by 2 times, that is the 2d. According to the Newton's law of gravitation, we know F1 is equal to gm1 into m2 by d square. This is the equation 1. Now, when the distance between them is increased by 2 times, then d is equals to 2d. So this becomes 2d. So gravitational force between them is given by F2 is equals to gm1 into m2 by, instead of the d square, you have to write 2d whole square. Now F2 is equals to gm1 into m2 by 4d square. This becomes equation 2. Now from equation 1, this equation, and equation 2, we get F2, means F2 equation is this, gm1 into m2 by 4d square, that is the gm1 into m2 by 4d square, divided by F1. So by reversing it, d square by gm1 into m2. Now this d square and d square cancelled, gm1 into m2, gm1 into m2 both cancelled. Now F2 is equals to F1, that is the 1 by 4 F1. Hence, gravitational force between them is decreased by 4 times. Here not increased. Gravitational force between them is decreased by 4 times when the distance between them is increased by 2 times, keeping the mass constant. So similar cases will come in the ACE. So by solving this, you can solve the this type of equation which will come in the ACE examination. Gravity and gravitational field. The earth attracts everybody toward the center. This is the marker. If you drop the marker, it falls toward the Earth center. Not only the marker, if you throw anybody in the space, it falls toward the center of the Earth. So Earth attract everybody toward the center. So you can say that gravity is the force that pulls the body toward the center of the Earth or planet. The SI unit of gravity is Newton. This gravity is a vector quantity because it have both magnitude as well as direction. This is suppose Earth or any planet. So it have the radius and mass. So gravity of the Earth or any planet depend upon the mass and the radius. So there is the more mass, more gravity, more radius, more gravity. So this depends upon the mass and radius. Next one, gravitational field. The gravitational field of planet is the area around the planet up to where gravity of planet had its influence or effect on the object. Suppose this is the marker. So if you throw it, it again falls. But suppose this is the bullet. In the science there is the suppose, you have to suppose this is the bullet. If you fire the bullet with such a force, so it never returns on the Earth's surface, means it go beyond the gravity, means up to when it remains up to the gravity, then it remains on the Earth, but when it is beyond the gravity, it never returns. So that's why the gravitational field of the planet is the area around the planet up to where gravity of the planet has its influence or effect on the object, and it also depends upon mass and radius of the planet. And gravity of planet or heavenly body can be calculated on the basis of the Newton's law of gravitation. That is the gravity, you can denote it by the F, weight, but that is also called the weight because gravity is the force which pulls, that is the weight also. So gravity or weight is equals to G m capital M small m by R square. That is this force is equals to the weight, or F is equals to W is equals to G m1 capital M small m by R square, where this F is equal to force, sorry, gravity, W is equals to weight, and this capital G, this is called the gravitational constant, this M, mass of the planet, this M, mass of the body, and R is the radius of the planet. Consequences or effect of the gravity. We can see the many buildings and the bridges. So stability of the buildings and bridges due to the gravity. We can feel our weight. Everybody have the weight, that is due to the gravity. Falling of the body toward the center of the earth, means any body falls toward the center, that is due to the gravity. We can walk on the earth due to the gravity. We can stand on the earth due to the gravity. Water can flow in the river due to the gravities. So these are the consequences or effect of the gravity. So gravity is most important for us. Without gravity, nothing is possible. These are possible. So that's why gravity is very important.